Hello everyone, I am M. Skandashambit and today I will be presenting my MERN Stack internship project titled Food Giene. Food Giene is a complete food ordering and restaurant management platform developed using MERN Stack, which consists of MongoDB, Express.js, React.js and Node.js. The objective of this project was to build a real-world web application similar to popular food delivery platforms like Swiggy and Zomato, where users can browse restaurants, explore menus, place food orders, make sure online payments, and manage their order history. Along with customer functionality, the application also provides administration features for managing restaurants, menus, and customer orders. Throughout this internship, I gained practical experience in front-end development, back-end development, database management, REST API development, authentication, state management, and payment gateway integration. In this presentation, I'll first explain the project throughout set of slides, and after that I'll demonstrate the complete application with a live walkthrough. So without further delay, let's start. As you can see, the project is called Food Giene. Food Giene is a full stack restaurant management and food ordering platform built entirely using MERN Stack. The inspiration behind this project came from modern food delivery application that allows customers to conveniently discover restaurants, browse menus, and order food online. Instead of creating a simple CRUD application, my objective was to develop something that closely resembles an industry level application with proper architecture and modern technologies. This project combines front-end development using React, back-end API development using Express and Node.js, MongoDB for data storage, secure user authentication using JWT, and strip payment integration for online transactions. Over the course of this internship, I learned how all the technologies work together to create a complete full stack application. Now, let's move on to the project overview. Food Giene is designed as completely online food ordering ecosystem. The application allows customers to search restaurants, explore menus, add items to their shopping cart, securely complete payments, and manage their previous orders. To make this project more realistic, I populated the database with over 50 restaurants and approximately 2,436 food items, covering multiple cuisines and categories. Instead of using dummy placeholders, the application works with large datasets, giving user an experience similar to commercial food delivery platforms. Another important feature of this project is secure authentication. Every user has to register and log in before accessing the protected functionalities. Authentication is handled using JSON Web Tokens, while passwords are encrypted using bcrypt before being stored in MongoDB. The application also integrates the strip payment gateway, allowing a secure online payment processing during checkout. Apart from customer functionality, the project also includes administrator capabilities where restaurant menu items, pricing, and customer orders can be managed efficiently. Overall, the goal was to build a scalable and realistic full stack application rather than a basic demonstration project. Now that we have looked into overall project, let's discuss the major features provided by the application. The features of Food Giene can be divided in two major categories. The first category is customer features and second category is administrator features. Let's first look at the customer side. The user can browse all available restaurants from the home page. Since the application contains multiple restaurants and thousands of food items, search and filtering functionality has been implemented to help users quickly find what they are looking for. Users can filter restaurants based on cuisines, ratings, or categories, making navigation much easier. Once a restaurant is selected, the complete menu is displayed with food names, description, prices, and other details. Users can then add multiple food items into their shopping cart. The shopping cart is automatically updated quantities and calculates the total bill dynamically whenever the products are added or removed. After reviewing the cart, users can proceed to checkout where Strip handles secure online payment processing. Once an order is successfully placed, the order details are stored in the database, allowing users to review their order history at any time. Now, let's look at the administrative features. The administrator dashboard provides complete management functionality for the application. Administrators can add new restaurants, update existing restaurant information, remove restaurants if required, and manage menu items. They can also update food prices, modify descriptions, add new dishes, remove unavailable items, and monitor customer orders. These operations are implemented using CRUD functionality through REST APIs connected to the MongoDB database. Separating customer functionality from administrator functionality makes the application more organized, scalable, and secure. These features together provide a complete restaurant management ecosystem instead of just a simple ordering application. Now that we have understood what the application can do, let's move on to technologies used to build the project. Now that we have discussed major features of the application, let's look at the technologies that power the entire system. Giene follows MERN Stack architecture where each technology has a specific responsibility. Let's begin with the front end. The front end of the application is developed using React.js. React allows us to build user interface using reusable components, making application modular, maintainable, and easy to scale. Instead of reloading the entire web page whenever the user performs an action, React updates only the required components, resulting in smoother and faster user experience. For the state management, I have used a Redux toolkit. Since multiple components need access to common data such as an user information, shopping cart contents, restaurants, and orders, Redux provides a centralized store that eliminates unnecessary prop drilling and simplifies data management across the application. Navigation between different pages is handled using React Router version 6, which enables smooth client-side routing without refreshing the page. For the communication between the front end and the back end, I used Access. Access sends HTTP requests to the backend APIs and retrieves the data such as restaurant lists, menu items, user information, and order details. To design the user interface, I used Bootstrap, which helped create a responsive layout that works well across different screen sizes. Now, let's move on to the backend. The backend is built using Node.js along with the Express.js. Node.js provides a JavaScript runtime environment for executing server-side code, while Express.js simplifies backend development by providing routing, middleware, and API handling. All business logic, authentication, database communication, and request processing happens within the Express server. Application database is MongoDB. MongoDB is a NoSQL database that stores information in flexible JSON-like documents called bcrypt documents. This flexibility makes it easier to manage restaurant information, menus, users, and orders without requiring rigid table structures. To interact with MongoDB efficiently, I used Mongoose, which provides schemas and models that simplify database operation. Security is one of the most important aspects of any web application. For token user authentication, I implemented JSON Web Tokens, commonly known as JWT. When a user successfully logins, the server generates a secure token. This token is sent back to the client and used to authenticate future requests without requiring the user to log in repeatedly. Passwords are never stored in plain text. Instead, I used bcrypt to hash passwords before storing them inside the MongoDB. Finally, the application integrates Strip for online payment processing. Strip provides a secure, reliable payment gateway that allows customers to complete online transactions without exposing sensitive card information to the application itself. Overall, each technology in the MERN Stack contributes to building a scalable, secure, and modern full stack application. Now that we have explored technologies used, let's understand how these components work together throughout the system architecture. This slide explains how different parts of the application communicates with each other. The architecture follows a standard client-server model. At the top, we have React frontend, which acts as a user interface. Whenever a user performs an action such as logging in, searching for restaurants, add food to cart, placing order, front end sends HTTP request to the backend using Access. The request reaches the Express server, which serves as a central controller of the application. The server first validates the request. If the authentication is required, the server verifies the JWT token before allowing the access to protected resources. After validation, the appropriate controller processes the request. For example, if the request is restaurant information, the restaurant controller communicates with MongoDB through Mongoose to retrieve the required data. The retrieved data is converted to JSON format and sent back to the front end, where React updates the user interface dynamically. This same process is followed for authentication, menu management, shopping cart operations, order placement, and payment processing. The DB itself is divided into multiple collections. The user collection stores customer and administrator information. The restaurant collection contains restaurant details, including names, cuisines, ratings, and location. The food items collection stores all the menu items along with the prices, descriptions, categories, and restaurant references. Order collection maintains complete order history. The cart collection temporarily stores items selected by the user before the checkout. To allow communication between the front end and back end, I developed more than 30 RESTful API endpoints. The APIs handle authentication, restaurant management, and menu retrieval, shopping cart operations, payment processing, and order management. By separating the front end, back end, and the database into independent layers, the application becomes easier to maintain, test, and extend with full features. Let's go on to the project statistics. The application currently contains 50 restaurants with its own menu and restaurant details. Across these restaurants, there are approximately 2,436 food items covering multiple cuisines and food categories. In total, these food items belong to 49 different food types, providing users with wide variety of choices. On backend, I developed more than 30 REST API endpoints to handle different functionalities such as authentication, restaurant management, food management, shopping cart options, payments, and order history. Most importantly, all the planned features were successfully completed, making the application fully functional and ready for demonstration. Although the application is already complete, its modular architecture allows additional features to be added easily in future without requiring major changes to the existing code base. These statistics reflect not only the size of application but also practical experience gained through the internship. Now that we have understood the architecture, technical foundation of the project, let's move on to development process and see how the application was built step by step. This project was developed in multiple phases, with each phase focusing on a specific part of the application. The first phase involved setting up the development environment. During this stage, I configured both front-end and back-end projects, initialized the Express server, configured React, connected the backend with the MongoDB, and installed all the dependencies. Once the project structure was ready, I moved on to database design and user authentication. I created MongoDB schemas for users, restaurants, food items, shopping carts, and other orders. At the same time, I implemented secure user authentication using JWT bcrypt so that users could register login securely. After authentication was complete, I started developing the core REST APIs. The APIs handled all business logics of the application, including restaurant management, menu retrieval, shopping cart functionality, order placements, and payment processing. Once the backend API was functioning correctly, I began the front-end development. I designed React components for the home page, restaurant listings, food menus, shopping cart, checkout page, authentication pages, and order history. Finally, I connected the front end with the database and with the backend APIs using Access, tested all modules thoroughly, fixed bugs, and optimized the application to ensure a smooth user experience. Following this step by step approach helped me build the application systematically while ensuring that each module worked correctly before integrating it with the rest of the project. Now, let's look at how the front end was implemented. So the front end of FoodGenie is entirely built using React.js with component-based architecture. Instead of creating one large application file, I divided the interface into multiple reusable components. This approach makes the code easier to maintain and allow components to be reused across different pages. The application contains more than 27 React components. Some of the important components include the login page, registration page, restaurant listing page, etc. One important aspect of front end is state management. For this, I have used a Redux toolkit. Redux maintains a centralized store that holds important application data such as user authentication details, restaurant information, shopping cart contents, and order history. Because of Redux, different components can access the shared data without passing it manually throughout multiple levels of the components. This greatly improves code organization and scalability. Another important feature is responsive design. Bootstrap, along with custom CSS, I designed the application so that it adapts well to different screen sizes, including desktop, tablets, and mobile devices. Key achievements: this project allowed me to apply several concepts that are commonly used in real world software development. One of the biggest achievements was successfully developing a complete full stack MERN application from scratch. Instead of working on only front end or only on the back end, I gained experience in every layer of the application, including the database design, back end development, front end development, authentication, state management, and payment integration. Another achievement was integrating realistic data into the project. The application contains more than 50 restaurants, approximately 2,400 food items, making the user experience much more closer to the commercial food delivery platforms. Security was another important focus area. JWT Authentication and bcrypt password encryption ensures that user accounts maintain secure and sensitive information is protected. I also integrated step payment processing, allowing users to experience a secure online checkout workflow. From the front end perspective, I implemented a responsive user interface that works smoothly across different devices. Finally, the project follows a modular architecture with proper separation of concerns, making it easier to maintain, debug, and extend in future. Overall, the internship project has significantly improved my understanding of full stack web application development and strengthened my practical software engineering skills. Now, let's conclude the presentation by discussing the future improvements. Although the application is fully functional, there are several features that could further enhance its capabilities. One possible improvement is implementing real-time notifications using WebSockets. This would allow the users to receive instant updates whenever their order status changes. Another enhancement would be integrating Google Maps for live order tracking so that the customer can monitor the delivery location in real time. AI could also be incorporated to provide personalized food recommendations based on previous orders and user preferences. Developing a mobile application using React Native would make the platform accessible on Android and iOS devices while sharing much of the existing React knowledge. Additionally, an analytics dashboard could have been introduced for the restaurant owners to visualize sales, customer trends, and popular menu items. These enhancements would further improve the overall functionality and user experience of the platform. To conclude, FoodGenie demonstrates a complete understanding of modern full stack web development. Throughout this internship, I gained hands on free experience designing responsive user interfaces, developing REST APIs, managing database, implementing authentication, integrating payment gateways, and connecting all the components into complete working application. This project has strengthened both my technical knowledge and problem solving skills, giving me valuable experience in building scalable web applications. That brings me to the end of the presentation. Now I would like to demonstrate the application and show how these features would look in real time. So this would be the login page. We can log in using our credentials. If the user is new, they can register over here. For example, the name would be Skandasham. Email can be skndsham@gmail.com. Password 123456 7. Phone number. So you have an option for selecting yourself as a user, restaurant, or admin. I would go with user. Register. So yeah, so you get 50 restaurants here. You can say that's Bengaluru. So these are the available restaurants in Bangalore, CTR in Whitefield, MTR in Rajajinagar, Vidyarthi Bhavan in HSR layout, Udupi Shri Krishna at Jayanagara, Suksagar, Koramangala, A to B, Basavanagudi, SLV, Koramangala, Mayas, Marathahalli, Tahaza Tindi at Indiranagar, Halli Mane, Koramangala, Kamath, Electronic City, etc., New Krishna Bhavana. So let's go into one of the menu. So yeah, so you can see a chocolate shake, vada, image of the food, the name of the food, description, price, say add to cart, is it in stock or no. uh, let's go with idli 2. Let's add margarita pizza 2. And veg biryani or filter coffee. That's it. Let's go to the cart. So you can see whether what items you have added, and since we have a lot of items here, let's remove idli. I think I need another chocolate shake, so I would add another chocolate shake over here. So here you can check out, add your address. So you can just go with payment here. Here you can get total number of items you have added, was the subtotal and tax and total amount. That's it for the project. Thank you. Now that we have discussed the project architecture and have done with the live demo, that's how I built my application. Thank you.